Now, one fundamental characteristics of the objects that you create and you assign to variables is if they are mutable or not, or immutable. Objects like integers or like chars are immutable. Objects like arrays, we'll see in details arrays in a future, in a next segment, or strings, they are mutable. So here I can run this code. You can see this is a char, this is a string, and we can see that both the char and the integer or the float that you would make are not mutable. And the difference is that while mutable objects, they are in a certain way stored in memory directly, so you have this memory occupation of these immutable objects, and is assigned to a variable. The memory address of this number or this char is assigned directly to the variable. For mutable address, this is more indirectly, so you store only a reference to the correct address where you actually store the object. So let's see how this mutability or immutability property of the object affect their usage across the code. To do that, we create an array and we reference and we bind to the variable a that is itself the first element is an array and the second element is an integer. Further, the first element of the array is again itself an array, and the second element here is an integer. In order to understand the effect of this mutability property of Julia objects, let's go to create an object and bind to the variable a that is an array, all this one, and it's a nested array as the first element is itself an array and the second element, this 4 here, is an integer. Further, this first element is an array, whose first element again is another nested array with 2 integers, and the second element is a 3. So we create this nested of nested arrays and we bind it to the variable a. The first element of this big array, being an array itself, is mutable, while the second element, being an integer, is unmutable. Let's now doing 3 different ways of copying it, this big array. In the first way, we simply bind the array object to another variable. In the second way, we use the keyword copy, and what copy do, and we'll see an example of the effect, is that we, differently from this syntax here, with copy we create another object equal to the old one, and we bind this new object to C, to the variable C. Okay? Finally, the third way, we use the keyword deep copy. Deep copy is similar to C in the sense that create a new object, but it go deep down and it recursively create new object as he met the reference of them. So, and we are going to see now in a second, while this one just copy the object and the reference to C, this copy all the referenced objects down to the nested array and bind this new object that is at this point totally independent than our original object, bind it to D. So, given what I said, if I run this code C equal A, what should we get? Are the two objects bounded by referenced by C and A the same or not? You can, if you want, you can stop the video here and try to answer this question by yourself. Okay, so the result is true. The two objects, because we used copy, are the same, are made in the same way, are like two books that are two exact copy than themselves. They are the same pages, the same everything. They are two objects that are equal in a certain way. However, when we are going to use the three equals syntax, there we are going to ask, is really this the same, is not the same copy, but is really the same identical object? And the answer obviously is false, because C and A reference an object that is equal, but is a different object. To better understand this difference, let's going to change some elements here of this big array and see how B, C, and D are affected. Let's start by changing the second element of the array. So this 4, this integer, we change it and we transform in, we make it 40. So what we do really here? First, let's note that we modify our object. Here we change one element of the object and we change the second element to another immutable object from the integer 4 to the integer 40. So we rebind the position, second position of our array to another completely different object, but at the same time we mutate, we change our global array. So B is another name for our original array. Will it be changed or not? What do you think? Again, you can pause if you want. You can see here, but it is changed. Why it is changed? Because the object is the same. So if I change my object, this will be reflected also by B. What happened to C? We say that C is another object. So if I changed it, we can see that this change that I done here is not accounted in C, because C is an independent object. So much it is D. You can see here, this one is the first element of our array, and this is the second element, and we have, and here we have 4, we don't have 40. Now, let's do another interesting things. Let's change the second element of the first element, this 3 here, and make it 30. So what we do here? Note that we are not changing, we are not replacing this object, the first element, with another one like we did here. We are modifying it. We are modifying one part of this big object, and we are replacing only this object here, this inner object, but the object itself here is an array, and it doesn't change. It is not replaced with another object. It is modified. So what happen will be? Well, B is the same object, so obviously we have here 30 as well, is accounted for. What happened for C? Well, this is the interesting bits. You can see here that even C is changed. Why is that if we used copy? Well, what copy did was to copy here a sort of memory address of this object, but the object itself is not changed with another object. So C and A, they are different objects, but they share the memory position of this object here. So C, even if it's a different object, account for the modifications that we did here at this point. What about D? Well, D, different from C, went deep and copied everything. So that you see here that even in this case, D is not changed. It's really another object and completely independent from the object that is referenced by A. Finally, we go even more deep and we change the second element of the first element of the first element of the array, so these two here, and we change it to 20. Well, B is accounted, C is accounted, and D, even if you go a further level down, we saw here we have 20, here we have 20, and here, still here with D, this is D, is not changed, even if we went one level down, because D recursively go down to any level and copy and make a copy of all the objects. Finally, with what we do with this syntax, we just rebind A to a completely different object. So we create another object and we bind this object to the A identifiers. What happened to B? You can pause again. Well, B was binded to the original object which A was referring. So it is not changed. It didn't become 5 because this is A is reminded to another object. And so much we'll see and D, as you can see here, they remain binded to the same object. So all the mutability property is very important for the way that variables are handled in your code, and we will go back to this fact when we'll deal to functions and the way to pass parameters to functions.